think the most important problems should come from the users, right? Because it's important that we build these solutions with the consumer in mind. And right now we have the benefit of hearing feedback from the consumer. So I would say the biggest challenge is with regards to false alarms. So people tend to get a bit annoyed. So precision and accuracy of these systems is crucial moving forward, because we would like the consumers to embrace these solutions. So these can mean that we either need to improve the quality, the overall quality of our solutions, or actually address, and actually not or, and address some of the corner cases. And these corner cases are sometimes related to some physical obstacles like if someone is behind the seat, the front row seat, and they're sitting in the second row, they might not be visible to the camera. So that's why we're so excited to bring in radar into our system and be able to address some of these issues. So it can be either an adult that's behind the seat, or it can be a child that it's covered by a blanket. Some of these things are inherent limitations of the camera. So actually leveraging the radar for that is a great addition into taking a step further to meeting the expectations of the consumer and having them embrace this product.
So it's really just what Bogdan said was there's gaps between each of those sensing modalities. Camera-based solutions can see what's in the field of view, whereas radar can penetrate through seats and see down into the footwells where there might be a kid or something where the camera wouldn't pick up. And same thing like Bogdan said about a blanket covering a baby. You leave the baby behind with a blanket over it, and now you can still see that there's a living, breathing person inside the car with radar because of the micro Doppler sensing that it can do.
Yeah, so this platform is based on the TI radar 6844 and the Texas Instruments TDA4V entry level chip. So basically this platform enables cost-effective and efficient sensor fusion in combination of edge AI inference and let's say heterogeneous architecture of the both chips. So basically the first radar is processing data directly in the chip, so it can output either already processed data or it can output raw data. So we can do like additional sensor fusion on the main compute unit. And after that, TDA4, which is main compute unit, is doing AI processing with the vision stack, and we are overlaying those data. So basically we can do both, either early or the late sensor fusion with this platform.
So the key ingredient of doing computer vision on embedded systems is to actually leverage neural network processors. So all the processing is happening embedded, accelerated on these neural processors, and that is basically the part where we take the images from the camera stream and we produce information for that image, and we are able to understand what is actually happening in the car. So that is one of the key components, on top of which we have added additional algorithms from Texas Instruments that do a similar sort of processing, but on radar signal. So now we have two sources of information about what's happening in the car, some of them compensating for the limitations of the other, and by fusing these together we are able to produce refined results. So we are able to address issues like we were mentioning earlier about occlusions, where physically the camera cannot see, so then the radar steps in as it can see through objects and detect if there are additional things that the system needs to be aware about in order to make the car a safer place, addressing these corner cases.
Radar sees a lot differently than our eyes do. A camera sees like our eyes do, but radar is in a RF spectrum, and it is very good at detecting ranges to objects, and it's very good at detecting the changes in ranges slowly over time. So for example, your heartbeat, it can detect that by analyzing the signal using signal processing. So that's how it does a lot of classification of a living being versus a picture of a living being, whereas a camera might see them as the same. Also ranging, it can see also through the materials in the car, the non-metallic materials in the car. So that's where it's able to penetrate where, a person, as Bogdan was saying, is occluded by the seat, a camera just wouldn't pick it up.
First place, I would say it's because of its very cost-efficient platform and power efficient. So comparing to the cost, it gives significant performances, especially in the AI domain. And in general, this platform has everything what we need to build such a complex in-cabin monitoring solution. For example, it has interface for the camera, it has deep learning interface, deep learning accelerators, which allow us to efficiently execute all these complex models for detecting different objects and different features. And besides that, it has different units inside this core, which give us option to do efficient like image processing or some other tasks which are complex, and we need to offload that to some hardware units. And besides that, we have some general purpose CPUs which can be used for some custom tasks or activities. As you said, each company brings some specific expertise into this collaboration. On the first place, Tobii, they own this product called SCDO, which enable both DMS and OMS solution with a single camera, which is very important from the cost perspective. And D3 company basically brings expertise in, I would say, camera expertise and hardware, overall hardware. They build the final hardware. And I would say the HTEC provides overall end-to-end ADAS expertise by integrating different solutions into a single solution and optimizing and porting different algorithms to the specific platform, in this case, TI platform. And also by combining all this, let's say, expertise and experience, we are able to create such a complex system.
You know, a lot of companies have different expertise and come to the table with their expertise right now, whereas developing all that you need for this solution to come to market would take time for one company to get up to speed on all the different areas. So we each offer different areas that we're ready to go to market with, but we just don't have the market exposure, or we don't have the integration capability. So we each, like Stefan said, we each have things we bring to the table, and that makes it ready now versus having a delay to catch up.
Yeah, we're very excited to take the first step towards sensor fusion. And as we were saying in the last in-cabin, there was a lot of doubt around the concept of doing driver and occupancy monitoring from a single camera, and with that now being achieved, we have to think about the future. And as we've said for several times, we believe the future is in sensor fusion. So what we are presenting in this in-cabin event is the first step. We believe the first step. We're showing a number of features with the radar, but as Tom was mentioning, we can do so much more. We can go into heart rate detection with the ability of the radar to detect all sorts of motion. So we feel there are a number of other features we can build with radar, but we don't think it stops there. We believe that the future will be to actually start giving benefit to the consumer from all these sensing technologies, because OEMs will clearly want to capitalize on the hardware investment and maybe offer some features to the consumers, which consumers are willing to pay for. At the moment, probably consumers are not willing to pay for a regulated system, but we believe sensor fusion will be key in enabling OEMs to actually deliver this. So we are sure we're going to see depth sensing technologies coming into play, audio being used, maybe thermal cameras, neuromorphic, then the list goes on. So there are a number of new sensing technologies that we believe will complete this full picture and actually make the in-cabin space a context-aware one, and the sort of environment where that understands everything about the consumer and is able to offer a totally new experience and perception about the driving experience. So we're very excited to take the first step, but this is definitely the first step. We believe this has been a great milestone, but there are so many things that we will be doing moving forward, and we're very excited to be here and show this the first step towards what we believe is the future. So that's a great achievement for all of us. We're very excited with the partnership. it always takes, as Tom was mentioning, expertise in a lot of fields to make this happen. So yeah, we're happy we could partner and deliver this together. It was a great experience.